Hello everyone, and welcome to this lecture on the Process Product Matrix. This matrix was published by Haynes and Wheelwright in 1979 in the Harvard Business Review. Our objectives for this lecture are to understand just the basic differences between craft production and mass production. And we want to introduce briefly the benefits and disadvantages of mass production. And of course, we'll be coming back to these throughout the course in much more detail. But we want to have a basis here that we can start with. And for that also, we'll be using the process product matrix, which illustrates how different production types support different products. And this will give us a framework or background for our discussions about things like capacity, setup times, labor costs, productivity, etc. for the rest of the course. But of course, any discussion of mass production cannot leave out Henry Ford. And if you have time, this is a picture from Wikimedia Commons, but please look in the internet for some very interesting photos and some very interesting videos about the start of the automobile industry. But going back a few years, the invention of the automobile is most often credited to Carl Benz. In 1885, with a patent in 1886, Benz developed the first gasoline automobile powered by an internal combustion engine. And his was a three-wheeled vehicle with the engine and chassis as a single unit. And in 1886, Daimler produced the first four-wheeled vehicle with a four-stroke engine. Now, in the late 1800s, so just a few years afterwards, cars were produced in workshops. The customers would specify their car exactly, and these cars would be produced for each individual customer according to their individual specifications. You had skilled craftspeople who produced individual parts and components, and then you'd have skilled fitters who would fit the parts together. Now, the contractors who made the different components had different gauges. There was no standard gauging system. And it was also not possible at the time to cut hardened steel. So the hardened parts, which often came out warped from the oven, they needed to be further machined in order to be fit together finally to make the car. And obviously this limited production to very, very small quantities, and all was for a specific customer for specific specifications. Now, the key advance which allowed mass production to start was the interchangeability of parts. And this required the same gauging system to be used throughout the entire manufacturing process. And advances also in manufacturing tools allowed work on pre-hardened metals. So the parts could be made after the steel was hardened. Finally, this allowed parts to be interchangeable, and these then could be designed to be very simply fit together. Henry Ford understood this critical step, and in 1903, he set up assembly stands to build individual cars, the Model A. The fitters had to fetch the parts and still do some filing to make the parts fit together. They weren't quite interchangeable, but was getting closer, and Ford had the parts delivered then to each station to increase the efficiency so the fitters could just concentrate on their work. Now, as the story goes, Ford, observing the slaughterhouses, he saw that there were individual workers equipped with specialized tools, and each would perform a specialized task or particular task, and then the carcass would move on to the next worker, where the next worker would then perform the next task with his or her specialized tools. 1908, he then said, okay, workers would have single specialized tasks and would move from vehicle to vehicle. But he noticed that the walking around took time and caused congestion, so 1913, in his assembly plant in Detroit, the Highland Park assembly line, he introduced the moving assembly line. And we had then the assembly line mass production had started. And as we know, of course, that has been a huge success. Let's go then one step back and review the difference between mass production and craft production. For example, we're running a dog grooming salon, and we have 2 employees. We've got 2 dogs ready to be processed and a 2-step process. First, we want to wash our dog, and then we want to do the grooming, to brush. So to use the production lingo, our dogs are 2 jobs. We've got dog A and dog B, and we need to perform the service of washing each dog and then grooming them. We can't groom before we wash, so we have a specific sequence to our process steps. And we have 2 workers, so we have 2 options. We can operate as a job shop using the so-called craft production, where each worker is in charge of 1 dog. The worker will first wash that dog and then we'll groom it. Or we can operate as a mass production facility where worker 1 will specialize in the first task, for example, the washing, and the worker 2 will specialize in the grooming. And this means that dog A will move into the wash, and when worker 1 has finished washing dog A, he can start washing dog B, and dog A can move on to worker 2 for the grooming. And assuming we have a steady flow of dogs, then our operation continues smoothly throughout the day. Now, of course, we have advantages and disadvantages to both craft production and mass production. If you have specialized resources for each activity, you have specialized resources for each activity, and if you have enough business, which is in this case dogs, then you can move from craft production to mass production when there's enough canine customers to create a full-time job for a worker specializing in just one activity. Let's go through this a little more closely. What are some of the clear benefits of mass production? Well, the first is efficiency. This has to do with time and money. Each worker can specialize in a specific set of tasks, and these specialized workers can work faster as they perfect their work. Workers don't need broad skill levels. Activity-dedicated tools could be developed more easily and be optimized for this narrow set of tasks at hand. And there's no time wasted switching from one activity to another. In addition, quality improves because you have standardized production and limited tasks. Costs can be reduced and the productivity increases. And again, what do we need for mass production to work? We need activities that can be decoupled so that each worker can perform their activity in a standardized way and doesn't need to change their activity based on another part of the production. And also, what is important are the interchangeable parts. Any part can be used then for any product. But let's look at the challenges to mass production, and this is the basis for our course. We're going to be looking at the math behind many of these issues as well as the human issues. For example, for mass production, a process is divided into a workload of activities and allocated to workers. And this often results in the situation that some workers are idle some of the time. Now, what is this idle time? We'll see this in the next lectures as a waste, a non-value added activity which costs money. We could also have the problem that the available capacity on the machines or worker capacity is not used. For example, if there's a long setup time between different types of products on a machine, then nothing can be produced on that machine during the setup time. This can even block other machines or other workers from doing their jobs. This is also wasted time. This then leads to a risk of longer production lead times for our products. And we'll also see that this leads to higher inventories building up in our process. Also, we'll see that high inventories are a waste. And we have another issue. High inventories can lead to lower quality. Now, why? Defects that occur can be hidden when there's excess inventory of good parts available. This means that defects then can be hidden, preventing the problems from being acknowledged quickly, preventing them from being corrected. And finally, also very important, is in mass production, with very limited job responsibility, you can have worker boredom, demotivation, and disinvolvement in the process. And again, we're going to be looking at all of these in much more detail. Now we'd like to look at the product process matrix to again to get the idea of production and to make the link between craft production and mass production. Now this, as I said, it's introduced in 1979 by Haynes and Wheelwright in Harvard Business Review. It's a matrix which provides a logical organization of a process in two different ways. Across the top here we have the job view. This is related to the value creation. We have on this side the resource view, which is related to the resources that we're using related to the cost. Now, in the job view, we're moving from highly customized, high product variety to highly standardized, limited product variety. And to look at this in terms of volume, if you have highly customized products, those are produced in low volumes. Compared to highly standardized parts, you can produce in very high volumes. Now, on the vertical axis, we're moving from what's called the jumbled flow, or the job shop view, to a continuous flow. And the flexibility for these types of production flows, if I can write this here, is ranging then from very high in a job shop view to very low flexibility and continuous flow. On the other side, the efficiency moves from very low in the job shop view to very high in the continuous flow view. And we find a match here along the diagonal of our matrix. A job shop can handle a wide variety of jobs, customized jobs, but with low volume. Job shop is typically grouped by function or capabilities. It allows customization, so very high flexibility, and has very high work content. Here we're focused on the process. And for example, big projects fall into this job shop view. Hospitals also, for example, where each patient is a different job and sees that a different process, typical of a job shop view. Now, moving down to batch processing, here we have a little more product variety as units are processed in batches of chemical products which use similar resource or use the same resources for different products. The volume can be higher with higher efficiency. Batch processes are typically repetitive processes with modest batch sizes producing standardized modules. And for example, you've got here maybe food processing. The next is the assembly line, where you're looking at computer assembly or automobile assembly. Here you have larger volumes of faster paced production. Here we have an increased production efficiency, but more limited flexibility. And finally, at the other extreme, you've got the continuous flow. And here you have very high volume flows of one single product, very high efficiencies, but with long runs of continuous flows. And here the focus is truly the product. We're looking at steel, oil refinery, sugar refinery, chemicals, for example, commercial baked goods. Outside of this diagonal, you're going to have a mismatch. Makes no sense to try to produce a customized product in a continuous flow scenario. And likewise, it makes no sense trying to produce something that is highly standardized, very limited in a job shop. We've got in the course some examples, some videos from the internet of the different types of production. And we encourage you to look at these, and maybe you can share some of your own, so that people who are familiar or who are not familiar with manufacturing or familiar only with a certain type of manufacturing can get an understanding of the different levels that we have here, and get a feel for some of the concepts that we're going to be introducing, and discussing in the rest of the course. Thank you.